mathematicians, it's Justin again. You're just in time, too. I'm throwing a welcome home party for my friend Matthew. Will you help me finish these decorations for the party? So, I bought this banner that says, welcome home. But I want it to be more personalized, so I printed out his name on a piece of paper. The letters look okay, but they're smaller than I want them to be. I'm thinking about scaling the letters to make them as big as the letters on the banner, but I'm not quite sure what to do. If we start with the M in Matthew and put it next to the M from welcome, we can see a big size difference. But how much of a difference is it? Is it 2 times as big? 3 times as big? It's difficult to tell without more information. I've gone ahead and arranged the 2 letter M's here on this grid paper. Now, what could we do to figure out how much larger the big M is compared to the smaller m? Let's count the dimensions. The smaller m is 2 units tall, and the large m is 10 units tall. For the width, the smaller m is 3 units wide, and the larger m is 15 units wide. Our goal is to make the smaller m into the same size as the larger m. What could we mathematically do to go from 2 units tall to 10 units tall? Pause here and see what you can come up with. So, how can we go from 2 to 10? Well, I know that 2 plus 8 equals 10, so maybe we just need to add 8 to both measurements. Since we need to scale equally in both directions, let's see if adding 8 to the dimension works for the width as well. The smaller m has a width of 3, and if we add 8 to it, just like we did with the height, 3 plus 8 equals 11. 11? Ooh, the width of the larger m was 15, and here we got a width of 11. If the width was only 11, it would squeeze the m in too tight. So adding the same measurement to both dimensions did not work. What else could we try? Ooh, I know. Let's try multiplication. 2 times 5 equals 10. I wonder if that'll work for the width this time. The smaller m has a width of 3. If we multiply 3 by 5, what do we get? 3 times 5 equals 15. That's the width of the larger m. In order to go from the smaller m to the larger m, we had to multiply both dimensions by 5. This is great. I'm going to finish adjusting the rest of the letters in Matthew to finish this sign. Taking a smaller image and making it larger is called scaling up, since the size increases or goes up. I wonder what will happen when we try to make something smaller. Here's an idea. These name tags I made are too big. What should we scale by to make these smaller? To make the letters in the sign larger, we multiplied the length and width by 5. Since we want to make these name tags smaller, we must need to use a smaller number, but how small? Let's try a number that's less than 5. How about 2? Let's multiply these dimensions by 2 to figure out what the new dimensions will be. 12 times 2 makes a new width of 24, and 8 times 2 makes a new height of 16. Oh, something went wrong here. The shape got larger, not smaller. We're going to need to try something different. Are there any numbers that create a smaller product when we multiply them? Oh, how about fractions? What if we try using something like 1/2? Just like before, we're going to multiply by the scale factor we've chosen. 12 times 1/2 equals 6, and 8 times 1/2 equals 4. The new name tags are going to be 6 units wide and 4 units tall. Scaling down the name tags using a fraction of 1/2 made them smaller, and now they fit so much better. Taking a larger image and making it smaller is called scaling down, since the size decreases or goes down. Let's practice more with scaling up and scaling down. Now I want to make a banner to hang up. It's going to be made of triangles just like this. Each triangle is starting with a height of 4 units and a width of 5 units. My goal is to scale up these triangles to be 12 units tall and 15 units wide. I know that to scale something properly, I need to multiply its height and its width by the same number. What do you think we should multiply by to scale up the triangles? Pause here and try it out. What did you get? First, we want to think about 4 times what number equals 12? 4 times 3 equals 12. Now we want to think about 5 times what number equals 15. Does the same number work? Yes, 5 times 3 is 15. In this example, we have to multiply both dimensions by 3 to scale up the triangle. Great work. Scaling up by a factor of 3 in the last example worked well, but I think I actually want these triangles to be a little bit larger. To scale this triangle, let's go back to the original triangle and multiply each dimension by the same number. Remember that the smaller triangle has a height of 4 and a width of 5. What should we multiply by to scale up the triangle so that it has a height of 16 and a width of 20? Pause here and try this one out on your own. Did you figure out the factor? This time we needed to multiply both dimensions by 4. 4 times 4 equals 16, which is the new height we were looking for, and 5 times 4 equals 20, which is the new width we were looking for. These new larger triangles are gonna be perfect. Okay, we're almost ready for the party, but what's a party without a game? I bought these game boards that measure 20 units tall and 16 units wide. I want to scale them down to 5 units tall and 4 units wide to fit more on a page. Remember that because we're scaling down, we're going to need to choose a fraction as our missing number to multiply by. Pause here and try to figure this out. So, what do you think? In this case, we need to multiply both dimensions by 1/4. 20 times 1/4 gives us the new height of 5, and 16 times 1/4 equals the new width of 4. Okay, now that I'm looking at it, I actually think these game boards are going to be too small, so let's scale them down to a different size. Scaling the game board down by 1/4 worked well and made the game board smaller, but they ended up being too small. So to scale down the game board, we need to go back to the original board and multiply each dimension by the same number. Remember that the original board had a height of 20 units and a width of 16 units. What fraction should we multiply the dimensions by to get a new game board that is 10 in height and 8 in width? Pause here and work this one out on your own. So, what factor should we multiply by? This time we needed to multiply both dimensions by 1/2. 20 times 1/2 equals 10, which is the new height we want, and 16 times 1/2 equals 8, which is the new width. Thank you. This game and the boards we scaled down are surely going to be a hit. Factors are any numbers that we multiply by to find a new value, but these factors we use in scaling figures. So they have a special name, scale factor. The number we multiply the dimensions of a figure by to change the size is called the scale factor. The bigger the scale factor, the more the scaled up image will grow. And the smaller the scale factor, the more the scaled down image will shrink.
Thank you so much for your help with these decorations. Today, we scaled up images by multiplying by scale factors that are greater than 1, and scaled down images by multiplying by scale factors that are less than 1 using fractions. Ooh, that's Matthew. He is almost here for the party. Once you're done watching this video and finishing up your guided notes, you can move on to levels 1 through 2 in the online practice. Until next time, keep questioning, keep calculating, and remember, to scale up or scale down, the scale factor tells us how. See you next time.
Hey, hey.